Uh, I have already attempted this Feb-March 2024 P4 paper from physics. And I also asked some of the students to send their responses to this paper. And I have found about 12 places in this whole question paper which people have gotten wrong, and there are things that I think I should address. First, it's about the question number one. In there, this is a very common trap in IGCSE. They usually uh, try to confuse you with the units. So what they did here is they gave time in minutes and they asked you for the speed in kilometer per hour. So the point is, of course, speed is supposed to be the gradient of this curve here. Of course, speed is supposed to be the gradient. Maximum speed is going to be the gradient of the curve when it is the steepest. So this region of it is what you want to find out the gradient of. Okay, between B and C. Okay, so okay, you go there. It is your y2 minus y1 upon x2 minus x1. Okay, all right. You take 2 points. There it is. This one and this one. The x of this point is 7.5, y is a 1.25. X for this one is a 5, and y is a 0.4. So you go 1.25 minus a zero point 0.4 divided by this. But what one forgets here is the fact that you have the denominator here in minutes. So you're going to have to convert it into hours by dividing it by a 60, and only then would you get the correct value. 20.4 kilometer per hour is what it comes to. Again, a very common trap. So what do we learn here? We learn that we should always look into the units of the data given in the grid here to go about do any calculations in the parts of the question, the other parts of the question. This one is something which is again a very common IGCSE thing they do. A very commonly asked question. It has been asked many times. And why steel ship floats on sea water? And that is one of the reasons why. See, I go by checklist. I've got about 230 checkpoints that one should study in IGCSE physics. In videos later, maybe I'll give you the link to this checklist. But I want to show you something in here which I added a few years ago. Look at the 3.6 point, how metals float and how overall density helps submarines and capsules float or sink is actually a checkpoint. So that's a very important thing. Now, people have been saying, I'll show you some answers to this question. Let's see if I have this thing anywhere. People, I've seen them answer this one. They said that it has a huge area. Uh, the base of the ship is huge, and that is why the um, pressure reduces because pressure is force upon area. So area is larger. It's large because of the base, and that is why the pressure reduces. No, the point is, imagine a ship which has a part of it, the base of it, in the ocean. Okay, so you go, let's take two ships. One of them, all solid metal, let's say this is all steel, and one of them with steel only on the outer surface and air inside. Okay, one ship, ship number one, which is made out of solid steel, even the inside of it, you have steel, and here you have got it hollow, that's ship number two. Okay, now if you figure out the density of this thing, it's going to be density. Density is supposed to be mass by volume. And same here, mass by volume. Okay. Now, don't you see that mass of this thing, this this much of it, let's say this is your ship, that's your um, top of it, hmm, and that's your front view of the ship. Don't you see that the mass of this thing in that amount of volume is going to be much larger than mass of mass contained in this amount of the same volume. Look at that. This is exactly the same shape. The volumes are supposed to be the same. But you've got air in there. Of course, the mass of contained in this volume is going to be far more smaller than the mass contained here. Try to figure out the density for this thing. It will come out to be equal to that of steel, 7,900 kilogram per meter cube. Try to figure out the density of this thing. It will come out to be far lesser than that of water. Water is about 1030. Well, the density here is going to be far lesser than that. And that is the reason why a ship or these large vessels float on the seawater. It's because their overall density is less. The mass of this volume, the mass contained in this volume is far smaller than what it would have been if it was all solid. And that is what you need to tell them here. Steel ships are hollow and they contain air. Overall density is less than the seawater. That is your answer to this one. Let's go do another one. Okay, now this is one silly place where everybody got it wrong, and probably the reason why they have included it. Figuring out the ratio between the pressure exerted by the person and pressure exerted by the polar bear is not a crazy difficult question. But why is it here? Only because they know that people are going to get it wrong. I'll tell you. So pressure by the person, pressure by the human, divided by pressure by the polar bear. People have answered it to be as 0.125. And that was not the agenda of the question. What people did not understand here is that humans are actually capable of applying pressure which is 8 times that of a polar bear. And maybe they got it to be an 8, but they thought, oh, pressure by the person is 8 times the pressure by the polar bear. How is that true? So they did a 1 by 8 and answered it to be a 0.125. Okay. But all you had to do is figure out the pressure by the person divided by the pressure by the bear. And I think it actually comes out to be um, polar bear 5782. Pressure by the bear comes out to be 5782. That's the weight of it divided by the area, 1.12. And the pressure by the human comes out to be 84. That's the mass. And multiplied with a 9.8 divided by a 0.020. Well, this thing is bound to come out to be 8 times that. And humans are capable. So there is a good chance of you sinking into that ice. There's a good chance of you breaking that ice and you can go down uh, a dangerous hole in there, or maybe something that you may go find yourself caught in there. But bears, you've got 8 times lesser pressure. So that was one mistake. Another mistake, one thing I've seen that they ask you why, this is question number 5. This is question number 5. Why internal energy of the gas decreases? So, of course, if you have got lower temperature, you should know that temperature is nothing but the measure of average kinetic energy. If you are looking at lower temperatures, it actually means that the kinetic energy has dropped. Now, internal energy of a gas is supposed to be made out of several components, one of which is kinetic energy. So if temperature is low, it has come out of the reason, and the reason is kinetic energy must have reduced. Internal energy has one of its components as kinetic energy. So internal energy also comes out to be low for that system of gas. That is how you want to frame your answer for this one, okay? There are several answers. People try to, most of them got it right, I would say, but the connection was important. You should mention that internal energy depends on kinetic energy. Kinetic energy is a component of internal energy, okay? Okay, now we look into the question number 6. Okay. So the thing with question number 6 is you have to take a printout of the question to attempt this, or question paper to attempt this. What happens is that this length is actually the same as that length. Plus, the focal length on this question comes out to be this much, and this point is 2 times the focal length away from the lens. So this is actually the point 2f, and that is also the point 2f. Now the thing is, by eye, the object and the image look to be the same size. And if you have got your notes, you would see about lenses, if an object is placed at 2f, the image of it is going to be the same size. And that is what you had to do here. State 2 other characteristics of the image. It's the same size as the object. And probably the reason why they wanted you to measure the focal length, they wanted you to they wanted you to see that this point is actually 2 times the focal length away. This object is 2 times the focal length away, that they wanted you to see it, and the image will come out to be the same size as the object. Okay. Okay. Now, sixth, see, they're looking at a magnifying glass. Okay. Sixth part B, they're looking at a magnifying glass. Well, magnifying glasses work only when the object is supposed to be placed between the between the focus and the lens. So the X was supposed to be marked between F and the lens. First thing. Second, it has to be something which is on the principal axis. That's the position you want. So some of the people were like, put up an arrow and put an X out there. Well, that's like labeling the object. You wanted to show them the position of the object, so it should have been on the principal axis. That's what I think it should be. Okay. So that was another thing I wanted to say. And if it's a magnifying glass, always remember the image is gonna be on the same side. Image is gonna be created, if this that's the object, image is gonna be created somewhere there, same side as the object, and it's going to be further away from the lens. It's going to be further away from the lens than the object. So these two are the correct ones. Okay. So that was the seventh one. Now let's talk about the question number 7, a slightly technical one, and I would like to explain why people got it wrong. Now, see what they've told in this question, seventh part D, that the temperature decreases. Okay. Mm. So the temperature, this is your thermistor, and the temperature of it decreases. Well, thermistors in your curriculum are supposed to have an inverse relationship with the temperature. So in a way, the resistance of it is actually going to increase. That if the temperature goes down, the resistance has to increase. Okay. So next they ask you, what is the effect of this temperature going to be on the reading of the ammeter and the voltmeter? See, if the resistance of this thing has increased, of course, with these two in series with each other, you are looking at an increased overall resistance. Let's say it was 100, and now it's at 200 after the increase. The overall resistance earlier would have been 100 and a 480 added. That's 580 ohms. With the temperature reduced, and maybe the resistance has gone up to a 200, the overall resistance now is a 680 ohms. So the resistance has actually increased. If the overall resistance of the component of the circuit has increased, the current has got to drop. This is the overall current The ammeter is placed in a way it measures overall current. So, with the increase in the overall resistance, the reading on the ammeter is supposed to reduce. That's what you say about the ammeter. Second, about the voltmeter reading. Now, see, this voltmeter is connected at those two terminals. So it reads the overall voltage that these two are experiencing together, or you can say it's literally measuring the EMF of the battery. The way it is connected. See, if it was somewhere here, I would have agreed with a few answers. The point is, if this voltmeter is only on this thermistor and the resistance of it has increased, this thermistor will now ask for a larger share of the total voltage supplied. If this was a 12, earlier it may have been asking for a 4 and this guy may have been getting a 8. But with an increase in resistance, this voltage will increase, this share of the voltage will increase, and it maybe comes out to be a 6, and this guy will now get a 6 only. The voltages on individual components connected in series follows a simple formula. V1 by V2 is R1 by R2, where V1 plus V2 is supposed to be the total EMF supplied. If there is a larger resistance, it will ask for a larger share. So, of course, if this voltmeter was out here and the temperature decreases, the resistance increases, and that is why it will ask for a larger share of that 12 volts supplied by the battery. But you have the voltmeter connected across these two together. Sum won't change. The sum of the voltage, which this guy is going to read, is still going to be at 12 if it was given as 12. So the point is the voltmeter reading stays the same. A good lot of them got it right though, but this is one concept which is repeatedly asked in IGCSE. Okay, so they usually put up LDRs, light dependent resistors. They want to know what happens. I remember there was a question where there was a resistor here and there was a LDR. There was a LDR, and parallel to this LDR was a lamp, and they were like, the light intensity increases. Light intensity increases around that LDR. In the daytime, they say. What happens to the light bulb? See, if the light intensity increases, the resistance of it drops. If the resistance of it drops, from that source, this LDR will only ask for a smaller share of the total voltage. The lamp is in parallel to that LDR. So the lamp will also get the same voltage. I'll say it again. Light intensity increases, so resistance drops. So voltage also drops. The voltage share will also reduce. Since these two are in parallel, the voltage here and the voltage there, it's actually the same. Voltage across the LDR is the same as voltage across the lamp. So the lamp will actually get dimmer or it will turn off. And what you have here is is an automated system of lighting up a lamp. If it's day, the lamp will go off. If it's night, the light will turn on. So those are your automatic headlamps on the cars. Okay. So that's the kind of question they wanna ask here. Let's go. I'm gonna go do a few more now. Ninth. Yeah, this is a very standard answer. Remember, I'll go back to the checklist and I've made sure that this thing shows up in my notes very clearly. I'll show you the transformer bit. Hey, I'm not able to find it here. Oh, I think it may be in magnetism. Let me see. Yeah, there. Know why step up transformers are used to increase voltage during transmission, keeping power approximately constant since voltage and current are inversely proportional. Know that power losses in transformers are calculated using power equals I square R and the other power formulae are, and know that increasing voltage reduces current and this power loss is proportional to the square of the current. This reduces transmission power loss. Okay, so that is your answer. You how step up transformers reduce power losses. You need to tell them that power is proportional to the square of the current. You want to reduce the current. How would you reduce the current? To increase, you'd increase the voltage, and that is why you won't put up a step up transformer. For power to be constant, for V into I to be constant, you should know V1 I1 is equal to V2 I2, which means V1 by V2 is a I2 by I1. That's also a very important transformer formula. V1 by V2 is I2 by I1. They're inversely related. Increase the voltage, reduce the current. Okay, so that was one important thing. Huh. And this is your question number nine. The first one, the previous one was question number eight. Now we move on to the question number nine. Uh, they were like, what change will you observe if it was beta particles here? Well, even I did this mistake. The thing is, do you tell them that beta particles are going to be attracted to the positive plate? Of course, it's going to be attracted to the positive plate. But what one forgets, which I mean, I forgot the fact that beta particles are far lighter than alpha particles. So if alpha particles deflect, the angle they deflect with is not going to be as large as it will be for beta particles. You know, beta particles are going to go deflect like anything. Imagine turning a truck through a turn and imagine doing it with a bike. So it's far easier, you know, it can go flick, it's flickable, you know, these things. So they're very nimble in that sense. So the angle of deflection for beta is going to be far more greater than that of alpha. So we need to tell them they deflect by a larger angle. So that is one marking point. I think there must be. Okay, let's go look at the 10th one. Well, this is a little controversial, I would say. In a way, some people say it's supposed to be a red giant and they end up with a white dwarf in there. And I wrote a red supergiant and ends up with a neutron or a black hole. The point is, if you look into the syllabus, you will see that there are two life cycles mentioned. One for the stars which are smaller or equal to the size of the sun, and for the stars which are larger than the sun. Now, this is the life cycle. The point number two here is the life cycle of of a star which is the same size as the sun or smaller. You start with a nebula and you end up with a white dwarf or a black dwarf. The point is, you can, at the end of this cycle, end up with a white dwarf and a nebula around it. Okay, so there, and that nebula can lead up to some other star, creation of some other star. Or you can have a larger star, larger than the sun, start with a nebula and end with a nebula. You may have a red supergiant in the intermediate stages and a neutron star or a black hole or something at the center of that nebula. So the thing can end up with a nebula with a neutron star there. Okay, so or a black hole there at the center. So it depends when if you take out this path, red supergiant path, you'll end up with a neutron star or a black hole. If you start with a red giant, you can end up with a white dwarf. There is no issue with this one. Okay, so that was another one. And one more question here. That's the last one, which is the 11th one. The point was to know that uh, they asked you to show it in years. The t here uh, is supposed to be calculated in years. The time is supposed to be calculated in years. The velocity is given in meter per second. A radius is given in meters. So you will end up with a time value which is in seconds. You want it to be in years. So you are supposed to convert what you get here as t. That's what you're gonna get in seconds, and divide that by the number of seconds in a year, and to get to a 30. So number of seconds in a year, 365 days, 24 hours, 60 minutes, 60 seconds. That's the unit. That's the thing you want to add to convert this time in seconds to years. So these were a few popular mistakes everybody did. Okay, most of the people did, and that's what I wanted to discuss. That's it for today, and I'm gonna go bring you the checklist. This whole checklist I'm gonna discuss in the next lecture. That's it. I'll see you. Bye bye.